So multiplying fractions, we multiply across. Dividing fractions, we keep, change, flip. So we keep the first fraction, we change the sign, and we flip it upside down. This guy flipped. And then we multiply across, just like we did on our regular multiplication. It doesn't change if there's variables in it. Same process. So when we are multiplying these fractions, especially on this first one, I'm going to multiply across, top and bottom, and I'm going to rewrite. And when I rewrite it, I'm going to group my pieces together. So I'm going to put my numbers next to my numbers, my letters next to my letters. So my x's together and my y's together. So I'm going to rewrite this as 3 times 12 times x squared times y. Those are all the same pieces that were on the top up here. I'm just rearranging what order they're in. On the bottom, I'm going to do the same thing. 8 times 9 times x times y cubed. We could do all of our multiplication and then simplify. But let's see if we can simplify anything right now before we go too far. What pieces do we have, both top and bottom, that we can simplify out?
X and Y.
Specifically, that we
Regular X and regular Y.
the regular x's I have on the top, x and x. And then a separate thought, we can simplify the y and the y. I just wanted to make sure we weren't trying to cancel out an x.
12 and 9. Wait, never
What
mind.
about the 12 and the 9?
You can divide by 3.
We could divide both of those by 3. So I'm just going to do that. So my 12 and my 9, I can both divide by 3. That's going to leave me with 4 and 3.
And then 3 and 3 can be.
The 3 and the 3 will cancel out.
And 4 and 8.
And yeah, it's starting to get a little ziggy-zaggy up here. But if you can spot it, we can still do this. 4 and the 8 are both divisible by 4. It's going to leave us with 2 there. And now it's looking really, really crossy-outy up here. So we're going to find all the pieces we have not crossed out. So we have, I just have x squared on the top. And on the bottom, I have a 2 and a y to the third.
Are the 2 and Y together or separate?
They are being times together.
Okay. So we can just write it 2
2y
Y together.
to the third. Yeah. All the pieces are being multiplied together. If it gets too crissy-crossy-outy for you, rewrite it and then try and simplify again. We got really good at that. And this is one of those times that I think colors really helps, because you can see my thought here. The pinks cancel out the pinks. The red cancels out the red. The green cancels out the green. The yellow cancels out the yellow. So I'm trying to show you my thought process here on these cancels. I'm going to switch it to the marker, especially for this pink one. So the pink one canceled out the pink one. The yellow canceled out the yellow. The red canceled out the red. Just trying to make it so we can actually see what's happening here. Green, green. Purple, purple. I'll use the chunky marker so we can see it. So we multiply across, simplify. It's the same process we had when it was just numbers. That's our whole answer. This is our simplified answer over here. Questions on this first one? Because next we're going to do a dividing. So first things first, when we divide fractions, what do we do with it? Keep, change, flip. So I'm going to bring it down. My keep is 10 d to the 5th over 6 cd. My sign changes to be multiplication, and then my second fraction flips. 4c. 30 c cubed d squared. And now we have multiplying across. I'm going to rewrite again where we got our stuff grouped together. You don't have to. Once you start to notice stuff, you'll be able to take shortcuts and like multiply right here. But I'm going to rewrite so we can see all the pieces a little bit clearer. So I'm going to have my 10 times 4 times C times D to the 5th. And on the bottom, I'm going to have 6 times 30 times C cubed times D squared. And we're going to see what pieces can we cancel out. The C and C. What else we got?
Yes. Can you do 10 and 30, right?
10 and 30. That's going to simplify down and leave me with a 3 on the bottom.
Oh, no.
Say it. I was going to say it again.
And then 6 and 4.
The 6 and the 4, we can divide both by 2. It's going to give me 2 and 3 here. Anything else that's on top and bottom? So yeah, so I've got the D to the 5th and D squared. So that's going to leave me with 3 D's on the top, and the D squared cancels out. Then let's rewrite it if that's what we see. So what I have left now on the top, I have a 2 and D cubed over, I've got 3 times 3 giving me 9, C cubed D. Are we fully simplified? Yeah, I still have D's there. Yes, darling. The D cubed came from having D to the 5th on the top. So that's 1, 2, 3, 4, 5 D's on the top. And we saw that D squared, so I went D and D. So canceling out the things we have in common here, I can cancel 1D here and 1D here. But now we look down here and we notice, oh, I still have an extra D down on the bottom. So this D is going to cancel out with one of the D's from the top. So yeah, so our final answer is going to be 2D squared over 9C cubed. And that's our answer right here. Zoom out so you can see the whole thing. Yes, ma'am.
I don't see how you got 2.
The number 2? So we had these guys here. We had 10, 4, and 6 and 30. So the 10 and the 30, I divided both of those by 10. So we divided by 10, and I divided by 10. That gave me a 1 here and a 3 on the bottom. My 4 and my 6, I divided those by 3, or by 2, sorry. Divided by 2. 4 divided by 2 gives me 2. 6 divided by 2 gives me 3. I'm left with 1 times 2 on the top, giving me just that 2 up here. And my 3 times 3 on the bottom giving me this 9 down here. Okay? Good question. Good question. I want you guys to ask questions. If you don't know where I got a thing, please, 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 please ask. Just grabbing my coffee. Okay? Any more questions on this one? Because you know we're about to kick things up a little bit of a notch. Because this works where we can cancel the things out because everything's being multiplied together. When we have something like this where we're asked to multiply the fractions, here's where things are all being added and subtracted together. I can't do the multiply and cancel out stuff when it's being added and subtracted. So what we're going to do is we are going to factor first, then do our multiplying across and simplifying. It's y's instead of x's, but it's just y's.
Y plus 2 and y plus 5.
Yeah, but slow down. Let's write it out, goof.
That's why I guess I'm saying
Because what you just did when you guessed and checked was you did the X frame in your head. Yeah, that's all it is. Just write that down, what you did in your head, and that's enough. Okay? So what we're going to do is I'm going to color code because it really helps us see what's going on here. So I'm going to factor the top. We have our X frame. At the top, we go A times C, which is 15, and the bottom is 8. So our pair of numbers that multiplies to be 15 and adds to be 8 are going to be what? 5 and 3. Since our A value is 1, we don't need to use the box, so we can just put in our y plus 5 and y plus 3. My denominator doesn't have a y squared, so we're just going to bring that down. Y minus 6. I'm going to put it in parentheses so it matches all the other pieces. We're multiplying, so we're going to keep everybody in the same order.
It doesn't matter which one goes first.
Correct. If you put y plus 3, y plus 5, that's totally fine. So now we're going to do the same thing with the right pieces. Again, I have an A value of 1, so all I need is the X frame. My A times C, 1 times 18 is 18, and the bottom is negative 9. I need a pair of numbers that multiply to be positive 18 and add to be negative 9. Negative 6 and negative 3. So we're going to put y minus 6 and y minus 3. The denominator is it's formatted funny. I think I made a mistake when I was typing it. This is a difference of squares. It just looks weird. This is supposed to be y squared minus 9. Yeah. So that one we can do directly into our pattern. We don't even need the X frame. Square root of y squared is y. Square root of 9 is 3. 1's a plus, 1's a minus. So the difference of squares does save you work if you notice that pattern. So then I have these pieces all being multiplied together. That is exactly what we're going to do, because when we multiply them together, it's just all these same pieces just being times. Everybody's being times anyway. So we're going to cancel out the things we can. Which one was it that you noticed, Julima? The y minus 3s. One here, one there. What else do we have that can cancel out? The y plus 3s. Anything else? The y minus 6. So this whole thing simplifies down to be just y plus 5. So this whole gross monstrosity thing simplifies down to this. It is basically a line. So factor, simplify. That's all we're doing. It's the same process if it's dividing. You're going to do your keep, change, flip. We're going to factor, multiply, simplify. I want to talk us through one of these kind of story problems. This is example 4-ish in your book, but it's also an example on your paper. Please note, the second expression in the denominator, make that a 200, not a 20. If we do a 20, it don't work. I apparently mistyped a 0 because I'm good at typing. Lucky it's an easy change. All right, so this is a kind of story problem that you may or may not see again. That's bad. All right, so we've got, this is one of those story problems that we go, really? Because the logic on it is a stretch. But it's one of those things we're just going to roll our eyes really hard. So we've got the manufacturer is looking at rectangular planters. So that's rectangles. The length of the planter is that nonsense, and the width of the planter is the other nonsense. We want to find the area. How do I find the area of a rectangle? Area is length times width.
So that's what it
Length times width. So I happen to know the length is this thingy. So I'm going to write that. So our length is x squared plus 15x plus 50 over x plus 2. And I'm going to multiply that times my width. Oh, look, they happened to tell me my width as well. It's this guy.
is. You can cancel things out first.
You can. X plus 2. I'm going to do x squared plus 30x plus 200, not 20. And we're doing the exact same process. We are going to factor. We are going to simplify. We're going to call it good.
Can you simplify first?
You can, because there's one piece there that is simplifiable right off the bat.
Yeah.
Because I've got those x plus 2's in both places. We're still going to be doing the same process, so it's not a huge deal, but yes, you can absolutely simplify those. Because we're going to wind up with our two fractiony guys. When we take our purple one here and factor this, a times c is 50, and our bottom is 15. So what pair of numbers? It multiplies to be 50. As to be 15, it's going to be 10 and 5. I heard you. I am just going to finish my sentence. It's okay. It's okay. I appreciate the enthusiasm. I really do. I'm saying, I'm not ignoring you because I didn't hear you. I'm ignoring you because I'm going to finish my sentence. So we have x plus 10 and x plus 5. I'm still going to write my x plus 2 down here. I know a lot of us noticed that we could cancel that out already, but I'm going to write it down anyway. And then we're going to do the same thing with our blue. I've got my x plus 2. And the bottom, we're going to x factor. I've got a 200 on the top. That's my C value. And a 30 on the bottom. Yeah, multiplies to be 200, adds to be 30. I know you see it. We got our 20 and 10. Multiplies to make 200, adds to make 30. That's why 20 didn't work. So we wind up with x plus 20 and x plus 10. And now we're going to look and see if we can simplify things. The x plus 2's, let me switch my chunky marker here. X plus 2's cancel out. And the x plus 10's cancel out. Oop, different color. Yeah. So our answer is going to be x plus 5 over x plus 20.
You can't.
Correct. We cannot reduce it anymore. That is our answer. For our answers, I genuinely do not care if you have the parentheses around it like this or not. We are going to leave it in factored form. So if we have something where we have two pieces on the bottom, like we had kind of here-ish, we're not going to multiply them back out. So if I had, I'm going to go back here. If I had, not saying I had, but if I had x times x plus 20, we're not going to multiply it back out. Don't tell me it's x squared plus 20x. We're going to leave them in factored form. Okay? But that is it for today. So this is homework 9-1.
That's it?
That's it. You can do the rest of 9-1. These two are the just letters ones. No factoring. This one is just factoring, and this one is story problem. Yes, dear. Report card gates are going to be pulled today at 2 o'clock. So whatever it is, like right now, is what's going to be on the report card. Okay? Nothing closes and locks, so if we have things we still make up, it'll go back and add that and affect that and fix it. But they're pulling report cards today. Our quiz for this part of the chapter is a week from today. Next Wednesday is the Wednesday before spring break. A week from tomorrow is the college career fair, and a week from Friday is the start of spring break. So I will get the review out for us on Friday so that we have it.
Is there anything else that we learned before the?
We're multiplying and dividing, and then we're going to add and subtract them, which is what we're going to do tomorrow and Friday.
So this and then add.
And then add and subtract,
There's a going to be on the quiz.
and that's going to be what the quiz is. When we come back from spring break, we'll graph these guys, which is going to take like 5 days for us to figure out how to graph the dang things, because there's a lot of steps.
When's the test? Oh, April 24th.
So yeah, so we're going to do the quiz on the 22nd, and then the test is on the 21st, and the test will be just like the graphing stuff and what we do after. So story problem solving and graphing. It's going to use a little bit of the multiplying and adding stuff, but we will review that before we get there. I promise. Okay? But you guys get the rest of this time to work on that. If you still need time to work on the around the room, now is a great time. I do believe I have a lot of people who haven't turned that in here. I do have one that's got a no name on it that I think was in this class. Just turn in the problem trail. You don't need to turn in your notes for either of the days. If it doesn't have a name line on it, you don't need to turn it in.